Guys, in this video we will be seeing that how to make the model of electrolysis. So over here we have two bottles which connects the tube to these two bottles, from two bottles to two bottles. But make sure that this tube over here doesn't touches to the water. So when I plug in the current, you can see that some of the bubbles coming off. So it actually erupts from the top to it. So because air has a high density and it moves from one place to another. So you may be having a question that why do I connect one wire from this to the another wire over here? That's because we have an AC adapter. All the technology devices which you are using right now, your smartphones, fridges, everything are AC. So to convert to DC, I have taken one wire from this to this. So positive and negative attracts and changes it to DC. So over here we have the negative charge which is polluting a lot of air over here. So this collects and it stores over here. I think this is oxygen and this is hydrogen. If you wait for a long time, it will be coming. In this video, we will be seeing a process called the electrolysis. What is electrolysis? Something new, right? In this video, we will be seeing clearly about it. Electrolysis means electricity, and the oscillation is separating between two particles. Let us see how it is that. So let's take the DC current. Do not take the AC current. What is DC current? DC current is also called as the direct current. Direct current isn't moving. It just produces the positive charge and the negative charge. But if you take an AC current, if you take an AC battery and just take the battery and connect it to a bulb, this positive goes to the bulb, it blinks it and it goes, the negative starts it and the positive goes in. So like that only happen. But in this electrolysis, we shouldn't use the AC current. It shouldn't attract the positive and the negative because we are gonna use something special. So let's see how is that. So basically, now we are having a DC current. DC current just produces the positive and negative that you may know. So when these copper plates are being taken, so we use the plates like carbon, the copper and the platinum because these aren't the rusting material. So we have it. So add some sulfuric acid in it. Why? Because water isn't a pure conductor of electricity. If you keep the electricity, the negative and the positives only attract, even if it is in the DC current. So like that, if you have it, the DC current will produce the positive charge and the negative charge. So I'm just taking as positive. So over here, when you pass through it, the anode and the cathode. So the another form of positive and negative is called the anode and the cathode. So anodes attract anion and the cation, the cathode attracts the cation. So it's nothing but the hydrogen and the oxygen. But it is not over here, right? Let's see the next image. So over here, if you take a test tube and usually to connect it, the cations and the anions attract. It is nothing but the hydrogen and oxygens attract. The hydrogens attack to the anions, and it may. So this one is the wrong slide, I guess. Okay, it's correct. So this H2O, H acts to the anions, and O or the oxygen contains the cations. So it too attracts and it separates. And if you take it and fire the hydrogen, it should be in a blue flame. So now thank you guys.